Hello everyone. In this video, we will be talking about the second part of Congruence Transformations, lesson 4-7. In this example, we need to verify congruence after a transformation. We have the original figure, which is point R, S, and T, and then after the transformation, it becomes the point W, X, and Y. So obviously, it's going to be a triangle. Let's first plot the points and then see what kind of triangles we have, and then after that we will be using distance formula to show that each side is congruent to one another so that the triangles are congruent. So let's get started by plotting triangle RST. Here's point R, point S is over 5 up 0, and then point T is over 5 up 5. So it's a right triangle. Here's the first one. The sides are 3, 5, and the hypotenuse is unknown. It's going to be radical for 34 once we calculate it. So the second triangle after the transformation is W, X, and Y over 3 down 7. Let's plot this one right here. Point W, X is over 6 down 7. Point X. And then the third point of the second triangle is point Y, go right 6 down 2. So these are the two triangles that we have. The red one is the image, the first one, the blue one is the original triangle. What we need to do is finding the length of each side. So the length of TS would be square root of, let's write down the coordinates up here. 5 point S is 50, R is 20. So what we need to do is we're going to subtract X coordinates and then Y coordinates and then square them, find the length. So the first one is going to be 0 squared, the second one is going to be 5 squared. So the length of the side is 5 units. Just by looking at the figure, by the way, we can confirm this because from T to S we go 5 units. So the second side is side RS. Let's find the distance between R and S. It should be 3 because when we look at it, it's easily seen. So subtract the X coordinates, square it, do the same thing with the Y's. So the first one becomes 3 squared, the second one is 0 squared, so we have square root of 9, which is 3. The last side of the first triangle is TR. Let's do the same thing and then find the distance. 5 minus 2 squared plus 5 minus 0 squared. So the first number is 3 squared plus 5 squared. When we do the math, we get 34. Okay, this is what we have for the first triangle. Let's figure out the side lengths of the second one. W has the coordinates of 3, -7. X is 6, -7. Y is 6, -2. So let's get to work and then find the length of YX or XY. So find the difference between the X values, square it, do the same thing for the Y. The first one is 0 squared, the second one is 5 squared, so we get square root of 25, which is 5. Now the second side, the shorter leg, is XW, 6 minus 3 squared plus -7 minus -7 squared. 6 minus 3 is 3. This becomes positive, and then they cancel each other out. Plus 0 squared, square root of 9, which is 3. The last side of the red triangle is YW, and the length of this side is 6 minus 3 squared plus -2 minus -7 squared. Right here we have 3 squared. -2 minus -7 is +5, and square that one, we get radical 34. So now at this point, what we are going to do is we identified it. Did we identify the transformation? I don't think so. So, okay, the first figure was this one right here, and then it goes down 2, 4, 6, 7 unit down, 1 unit to the right. So this is a sliding. So what was the options? Reflection, translation, and the last one was rotation. So since we are sliding, this one is going to be translation. So the type of the transformation, the answer of this part, identify the transformation, is translation. The second part, verify that it is a congruence transformation. So we just did that. Since all the sides are congruent, 5 and 5, they're congruent, 3 and 3 are congruent, 34 and 34 are congruent. So what we need to do is triangle TSR is congruent to, we are going to name the second one YXW. So we verified it by showing that each side are congruent to one another.